Morning to all of you.
Good morning, sir.
Good morning. Yeah. Are there any questions, doubts? Yeah, any questions, doubts so far whatever we have discussed?
Sir, what do you mean by that recursive relation? Means
Recursive
what
relation
exactly?
means that we know the value of the that particular term in the previous time step. So that's a relationship between the value of the variable at current time step and previous time step. That is known as recursive relation. So if you know the previous value, you can calculate the current. If you know the current, you can find the next value. इससे भी class चल रही है. So that is what is known as the recursive relation.
Sir, are we referring the previous value on the basis of time only?
Yeah.
Okay, sir.
Yeah. Any other question, doubt? So if there are no questions, let me start. So we are discussing viscoelasticity. So I was discussing the constitutive relation for linear isotropic viscoelastic solid for a 3D case. So is my screen visible?
Yes, sir.
Okay. So I am continuing with this. It is not writing. So let me close. Oh, it is. Hmm. My system has hanged. I think it is not working. So let me. There is some problem. So what happened? Hello.
Sir, you are audible, but screen is not visible.
Yeah, actually, my system, it seems it has hanged. So I'm not able to do anything. And I'm trying to. I'm trying to reset it. So that is also not happening.
So you can force restart the system.
No, I'm. No, it is not. That is also I'm not able to do. Nothing. No, nothing is working. No button is working. No click is working.
So long press the power button. It will restart the system.
This is tablet, no? So I am trying to
Okay.
do that. Yeah, but it is not working. It is a tablet actually I'm using. Hello, am I audible?
Yeah, now it is visible.
And okay. So okay, then let me start. So I was पवन अभी मेरी क्लास चल रही है. No, I'm not able to write in the screen. I don't know. Let me close this and open it again. Again, it has hanged. I don't know what is happening. Yeah, again it has hanged. I'm not able to do anything. I don't know what happened today.
Sir, is the memory of your tablet full?
No, I don't think that will be the case because it is hanging. Now I'm not able to do anything. It restarted after restart also the same problem. I'm trying again to restart it. Yeah, please stay online. I'm trying to restart. Hello, am I audible?
Sir,
And is
we
the
can hear.
screen okay?
The screen
So
is visible to.
okay. So let me see if it works now. So yeah, we are continuing with the viscoelasticity. So last class I was talking about this delta sigma xx corresponding to nth step, and which is we said it is twice, and then integration 0 to tn, and then we have summation I going from 1 to n, and then gi e to the power minus tn plus 1 minus t dash upon tau I minus e to the power minus tn minus t dash upon tau I, and this whole thing is then we have epsilon xx minus 1 upon 3 into epsilon v. Then this what we have is d of epsilon xx by dt dash minus 1 upon 3 d epsilon v by dt dash into dt dash. So this is where we were. So first and third term we said no, we can write it like this. So then I had also said that we want to derive recursive relation for delta sigma xx n comma I. So for that I said let us consider contribution of, let us consider ith term. So for that I had said now we denote that by delta sigma xx n comma I, so ith term of this. So that is twice integration 0 to tn, and then gi we have e to the power minus tn plus 1 minus t dash upon tau I minus e to the power minus tn minus t dash upon tau I into d of epsilon xx by dt dash minus one third of d epsilon v by dt dash into dt dash. So this is what no the last class I was talking about. So now in this we want to get an recursive relation. So let me explain. So now as far as this term is concerned, here we are having tn plus 1 and here we are having tn. So we know that this tn plus 1 is equal to actually tn plus delta t. So we substitute this, so then your delta sigma xx n comma I can be written as, because in place of tn you will write that, so then you can take this e to the power minus tn minus t dash upon tau I as a common. So if you take that as a common, so you will get this 2, and this is one term we will be having, which is minus delta t upon tau I minus 1. So this will be common term, and then we will have 0 to tn. You can stop me anywhere, no, if you have no, if you don't follow anything, or no, you have a doubt. So then this is tn, and then we have gi e to the power minus tn minus t dash upon tau I into d of epsilon xx by dt dash minus 1 upon 3d of epsilon v by dt dash into dt dash. So now if you look at what we want to do is we have this term as a common one. So let us say that delta sigma xx n comma I. This is, let us write it as this term what we have, and we are going to define the rest of the things as another term. So we will have e to the power minus delta t upon tau I minus 1 into delta s. Now I am using another notation, sxx n comma I. Now where this delta s xx n comma I is twice of integration 0 to tn gi e to the power minus tn minus t dash upon tau I into d of epsilon xx by dt dash minus 1/3 of d of epsilon v by dt dash into dt dash. So yeah, this is, now we are for this we want to derive the recursive relation. So now let me say that this delta s xx n comma I, this quantity, it is integral 0 to tn, and the integral, now we want to express this delta sx n comma I in terms of delta sx n minus 1 comma I. See, the n is denoting the time step number, so this is nth time step. We want to write it in terms of n minus value of this quantity in terms of n minus 1th time step. So this we can write as somehow, this integration can be split into two parts, 0 to tn minus 1 and then tn minus 1 to tn. So twice integral 0 to tn minus 1, and then we will have gi e to the power minus tn minus t dash upon tau I into d of epsilon xx by dt dash minus 1/3 of d of epsilon v by dt dash into dt dash, and then plus the integral twice integration from tn minus 1 to tn, and then the other things are same actually, gi, the integrand is same, gi e to the power minus tn minus t dash upon tau I into d of epsilon xx by dt dash minus 1/3 of d of epsilon v by dt dash into dt dash. So now what we want is this quantity, this can be evaluated, because now we will assume that tn minus 1 to tn the strain rates are constant. So we will assume this constant and we can evaluate this integral. And whereas this, tn, we know again that tn is can be written as tn minus 1 plus delta t. So we know that tn is equal to tn minus 1 plus delta t. So if you do that, so you can see that we can write, as far as this term is concerned, you can write it as, then you can say, that delta sx n comma I, this can be written as twice and integration 0 to tn minus 1, and then you will have, now tn we are writing as tn minus 1 plus delta t. So you will have by e to the power minus delta t upon tau I as a common term. So we will have e to the power minus delta t upon tau I common, and then you will have this gi e to the power minus t n minus 1 t dash upon tau I, and into, of course, d of epsilon xx by dt dash minus 1/3 of d of epsilon v by dt dash into dt dash. So that is how you can write this term, and plus the second one, twice integration from tn minus 1 to tn, you have this gi e to the power minus tn minus t dash upon tau I. And now again, for each interval we assume that the strain rates are constant. So this can be for tn minus 1 to tn. Of course, this rate would be different from what we have from tn to tn plus 1, but it will be constant. So let us say I'm using the same notation, Rx minus 1/3 of Rv into dt dash. So you can write it like this. Now if you look at these terms, so you can say that this delta Sxx n comma I will be equal to, now if you see, essentially what we have is not this factor e to the power minus delta t upon tau I. Otherwise rest of the thing is integral 0 to tn minus 1 gi e to the power minus tn minus 1 t dash upon tau I into this d of epsilon x dt dash minus 1/3 d of epsilon b by dt dash into dt dash. So that is essentially delta of Sxx n minus 1 I. So you would see that what we are getting here is minus delta t upon tau I into Sxx n minus 1 comma I. So this term is e to the power minus delta t upon tau I into Sx n minus 1 comma I. So that's the first term. And for the second term, if you do the integration, now this is constant, so this can be taken out of the integration sign, and you have to just integrate e to the power minus tn minus t dash upon tau I. So if you carry out the integration for that, you will have twice of gi into tau I, and then we will have Rx minus 1/3 of Rv and into 1 minus e to the power minus delta t upon tau I. So if you evaluate the integral and put the limits, this is what you will get. So then finally the final recursive relation for this Sxx n comma I is that delta of Sxx n comma I is equal to e to the power minus delta t upon tau I into delta Sxx n minus 1 comma I, and plus we have twice of gi tau I, and we divide and multiply it by delta t. So we will have here upon delta t, and then into you have this 1 minus e to the power minus delta t upon tau I, and then because we have multiplied and divided by delta t, so we have delta t into Rx minus 1 upon 3 delta t into Rv. So that would be delta epsilon xx minus 1/3 of delta epsilon v. So this is what I was talking about. No, so this is a recursive relation. This is a recursive relation. So now you don't have to store for all time steps. You have to just store this value for the previous time step. Of course, this you have to do for all the no i's. So depending on what capital N you are choosing, so that many values, and for all the components of stress. So same thing you can do for the sigma yy sigma zz. So you can write similarly delta sigma yn delta sigma zn. You can write in a similar manner in terms of delta s yn comma I delta s zn comma I. So you can write the similar kind of a relationship. So now similarly, so this is exactly you can do this thing for the other two normal stresses. Now let's also see the shear stress. So now for the shear stress, now let me see the delta of tau xy. So that is why we started with. So now if I look at the incremental shear stress from time step tn plus 1 to tn, so we will have this as tau xy at tn plus 1 minus tau xy at tn. Exactly the same thing what we did for sigma xx, I am trying to do for the tau xy. So by definition, we know from the Boltzmann integral that delta tau xy, this tau xy at tn plus 1 is integral 0 to tn plus 1 into g evaluated at tn plus 1 minus t dash into d of gamma xy by dt dash into dt dash, and minus integration 0 to tn. Now we am writing tau xy tn, so that would be integral 0 to tn and g of tn minus t dash into d of gamma xy by dt dash into dt dash. So now you can again this integral 0 to Tn plus 1 can be split into two parts. So we can write delta tau xy as integration 0 to Tn, and this remains same, g of Tn plus 1 minus T dash into d of gamma xy by dt dash into dt dash plus integral from Tn to Tn plus 1, and then we will have g Tn plus 1 minus T dash d of gamma xy by dt dash into dt dash. So the first term can be split into two terms, 0 to Tn and Tn to Tn plus 1. Minus, of course, the third term remains as it is, that is 0 to Tn g of Tn minus T dash into d gamma xy by dt dash into dt dash. So now let us do the same kind of a thing, that let us say this as a first term, this as the second term, and this as the third term, the way we did earlier. And in addition to this, as I said already, similar to normal strains, we also assume that within each time interval the strain rates are constant. So if I look at gamma xy from t say n to Tn plus 1, so it is constant. This axis is t, and this is the slope, your rxy. So based on this, you can say that gamma xy at Tn plus 1 is going to be gamma xy at Tn plus rxy into delta t, and so gamma xy at any time t dash will be gamma xy at Tn plus rxy will be t dash minus Tn. You can write it like this, rxy into, so this is rxy into t dash minus Tn. So you can write it like this. So now if you look at the second term, so let us first talk of the second term. So the second term we can write as integration, which is Tn to Tn plus 1, and then we have g of Tn plus 1 minus T dash into d of gamma xy by dt dash into dt dash. This is your second term. So now we can write it as, now let's put the value of g Tn plus 1 minus T dash. So will be integral from Tn to Tn plus 1, and then this whole thing is g infinity plus I equal to 1 to n gi e to the power minus Tn plus 1 minus T dash upon tau I into, we have dx, now d gamma xy by dt dash will be rxy into dt dash. And if you carry out the integration for this, so finally I think the steps are similar, so I'm not repeating that. So finally you can write this as g infinity into delta gamma xy. So g infinity into delta gamma xy plus delta gamma xy summation I going from 1 to n gi tau I upon delta t into 1 minus e to the power minus delta t upon tau I. So you can write it like this. Okay. So yeah, hello, am I audible? Yes, hello, am I audible?
You are audible, sir.
Yes, sir.
Yes.
Okay. Again it has hanged when I'm switching over from. Today I don't know what is happening here. Again it has hanged. I don't know what is happening. It is today. I don't know why it is hanging again and again. I'm not able to now do anything on the screen. I have to restart. Please be online. I'm restarting it again. Let me see if it works. Hello, am I audible?
Yes, sir.
Okay. And is the screen visible? Today
Yes,
I
sir.
don't know what is happening. Every time it is hanging.
It is visible, sir.
Yeah. So yeah. So I was just talking about the second term. So I had just written that it is g infinity into. Oh, it is not writing. Hello, am I audible? Hello, am I audible?
Yes, sir, you are audible.
Yes, sir.
And is the
Yes.
screen visible?
Yes, sir.
Yes.
Yes, sir.
Okay. Yeah, so hopefully let us see now if it works. So this I was writing the second term of uh, this delta tau xy. So that can be written as g infinity. It is not right. Hello, am I audible?
Yes, sir.
Yes, sir.
Yes.
Okay, so let me see if I can. Today I don't know, either some virus has come to my system or something has happened. So constantly it is creating problem. So yeah, this is. Let me at least try to do this delta tau xy term. I think that is what probably I can do. So this will be. We said that second term finally can be written as g infinity into delta gamma xy plus delta gamma xy into summation I going from 1 to n gi tau I upon delta t into 1 minus e to the power minus delta t upon tau y. So this is what I had said. So now let us go to second and third terms. Sorry, the first and third terms. So first and third terms put together. So both the terms put together, we are denoting that as delta tau xy, and we are giving a superscript n, denoting that this is for the nth step. And why delta tau? Because this is the difference of two g values. So by definition, if you look at already what we have seen, the second and third terms, if you sorry, the first and third terms, if you see, this is the first term and this is the third term. So in this you can take this d gamma xy by dt dash as common, because both the integrals are from 0 to tn. So you can write this as integral 0 to tn, and then we have g at tn plus 1 minus t dash minus g at tn minus t dash, and then into d gamma gamma xy gamma xy by dt dash into dt dash. So you can write it like this. And so we know we can put the values of g from the Prony series. So we can write this as delta tau xy n is equal to integration 0 to tn, and then we have this summation I going from g infinity gets cancelled. In both you will have g infinity, so g infinity gets cancelled, and then you have only these terms. So you can write this as now again you can take actually gi common, and so this can be written as gi e to the power minus of tn plus 1 minus t dash upon tau y minus e to the power minus tn minus t dash upon tau y into d gamma xy by dt dash into dt dash. So this is how you can write. Now this term can be, we know that tn plus 1, what we have here, no, in this we have tn plus 1 minus t dash, and here we have tn. So we know that tn plus 1 is tn plus delta t. So you making use of that relationship, we can actually write this delta tau xyn is equal to, you can write it as integration 0 to tn, and then summation I going from 1 to n, and you can write it as gi e to the power minus tn minus t dash upon tau y, and we are taking out no this term e to the power minus delta, no, we are taking this, we are writing tn plus 1 is equal to tn plus delta t, and then we are taking e to the power minus of tn minus t dash upon tau y as a common. So we will get e to the power minus delta t upon tau y minus 1 into d gamma xy by dt dash into dt dash. So you can write it like this, and this is since we know tn plus 1 is equal to tn plus delta t, so that is why we are able to write it like this. So now you can see, I take the ith term, then I can write delta tau xy n comma I, the ith term in that. So for that I can take this out common, so it will be e to the power minus delta t upon tau I minus 1, this will be common, and then integration 0 to tn, and we will have gi e to the power minus tn minus t dash upon tau I into d of gamma xy by dt dash into dt dash. So you can write it like this. Now we want to write this as in terms of earlier, like we have used sxx. Now we want to write it in terms of delta sxy. So we can say that this term e to the power minus delta t upon tau I minus 1, and this whole term, no, this whole entire term, let us say delta s x y n comma I. So now we want to look at this. So where this delta s x y n comma I is integration, and for the, yeah, this one e to the power minus tn minus t dash upon tau I into dxy by dt dash into dt dash. So now for this we want to derive the recursive relation. So again we split the integral from 0 to tn minus 1 and tn minus 1 to tn, and we do the similar thing. So you will find no, we can write this delta s x y n comma I is equal to integration 0 to tn minus 1 and then gi e to the power minus tn minus t dash upon tau I into d gamma xy by dt dash into dt dash, this term, and plus integration tn minus 1 to tn and gi e to the power minus, other things are same, t dash upon tau I d gamma xy by dt dash into dt dash. So you can write it like this. So yeah, so you can write it like this. And then now what we can do again, for as far as this term is concerned, we can write tn as tn minus 1 plus delta t. So then now you can see that we can write this term as delta sxy n comma I is equal to 0 to tn minus 1, and then we have gi e to the power minus delta t upon tau I will come out when we write tn is equal to tn minus 1 plus delta t. So we will have e to the power minus tn minus 1 minus t dash upon tau I into d gamma xy by dt dash into dt dash. And for the second term, because this is the integration from tn minus 1 to tn, so now for that what we can do is we take the gamma xy to be no linear of linear function of time from tn minus 1 to tn, so we can write that as rxy. So rxy can take common out of the integration sign, so I can write that as rxy integration tn minus 1 to tn and gi e to the power minus tn minus t dash upon tau I dt dash. Now you can write it like this. So then what you can do is, so let me see if it works. Again I want to increase the time, so if it works we'll continue, otherwise no. Yeah, so it's fine. So now now see, we can if you look at this, so this term is what we have here, no, in this case is no, this term we can write no in terms of delta sx y n minus 1 comma I. So you can write delta sx y n minus no n comma I. So this term, no, the first one, no, this particular term, I can write it as e to the power minus delta t upon tau I, and the remaining thing you see, it is like delta sxy n minus 1 comma I. So that is what that term is. And for the other things, if you do the integration, no, for this term, gi you can take out of the integration sign and you integrate from tn to tn minus 1 to tn. So if you integrate, you will get that as rxy into gi tau I and into e1 minus e to the power minus delta t upon tau y. So this is what you will get from this, and this is what you can write. So finally no, you can write this as delta sx n minus 1 comma I is equal to e to the power minus delta t upon tau y delta s x y n minus 1 comma I, and now we can multiply and divide by delta t over here. So this you can write delta gamma xy into gi tau y upon delta t into 1 minus e to the power minus delta t upon tau y. So you can, so this is another recursive relation. So now what I am saying is that no, you start with 0 time, and then no, you take the starting at 0 time, you delta s xx or delta s xy you take at 0, and then in the subsequent step you can make use of this kind of recursive relation. So this is for the shear stress tau xy, and know that we have already got the recursive relation for uh, this here, this one for the normal stress. Same thing now you can do for the other components of normal stress and shear stress. So based on this, now when we are solving a linear viscoelasticity problem, we just need to store the data for the previous time step. We don't need to store all time steps, and that is the advantage of using these recursive relations. So I think, yeah, I just want to stop here. I couldn't do today much because of this problem in my system. So I'm sorry for that. Now, if you have any questions and doubts, now you can ask so far whatever we have discussed. Yeah, so anybody, any question and doubt on this, whatever we have discussed so far? Okay, so if there are no questions and doubts, I'm stopping. Thank you all for your attention. I think because of the today this problem, I am one lecture behind. Yeah, thank you all for your attention.